Okay, today we're going to start looking at simplifying and performing operations with imaginary numbers. So we're going to learn about these imaginary numbers. So to get you started, I have a few blanks here to fill in. So like 3 plus what is 14, you'd have 11, right? 4 times what is 28, you'd have 7. 6 plus what is 4, you'd have a negative 6. 4 times what is 19? Get a little bit harder here, but right, if you think about that as like an x, divide both sides by 4, you'd have that question mark is 19/4. So it's a decimal, but still works. Okay, what times what is 49? 7 times 7, right? It's got to be the same number. What times what is negative 49? So you may try something like negative 7 and 7, but the problem is those are not both the same number. We're looking for two numbers that are the same. You can think about that as like an equation, x times x equals negative 49. So you get x squared equals negative 49. So you're taking the square root of both sides. So you'd have x equals plus or minus the square root of negative 49. And the question is, what number is that? And this is a number that we haven't actually talked about before, right? Where we have a negative in the square root. So that's where we actually get our definition of I. So to allow us to evaluate square roots with negative numbers, right, we use the following definition. A number that when squared gives a negative result. So in other words, the square root of negative 1 is going to be I. So when we square that, we will get a negative result still. Okay, so like up here, we're going to get there, but just so you have like it plus or minus, this negative on the square root means I. So the negative means I. And then the square root of 49 is going to be the 7. So this answer would be, oh, sorry, that looks like 2 7s. That's 7. Would be plus or minus 7i is the idea there. Okay, so we call these numbers complex, a plus bi. All numbers can be written in the form a plus bi, where a is the real part and bi represents the imaginary part. So technically, we can write any number that way. So here's some numbers. We're going to go through and identify the real and imaginary parts and then classify the number. So if you have something like 8 plus 1/3 I, the real part is 8, right? The imaginary part is the part that has I, so 1/3 I. So therefore, we call that a complex number, meaning it has both a real and an imaginary part. Okay, negative 4 plus 5i. The real part is negative 4. The imaginary part is the 5i. So therefore, once again, since it has a real and an imaginary part, we call it complex. This next one, we could say the real part is 0, or if you just want to put like a little dash for meaning like it doesn't exist, that works as well. I may just put like a dash, or 0. Okay, but it does have an imaginary part, 11i. So while you could think about this number as 0 plus 11i, and then maybe we call it complex because then it does have a real and imaginary part, in this case, it just has an imaginary part. Okay, next, with negative 76. That is just a real number, so that's just the real part. So we don't have an imaginary part, you'd say, or there's 0i, right? So we call that just a real number. And those are the numbers we're used to seeing so far. So we're going to go ahead and rewrite the radical using our imaginary unit I. So in each of these cases, you can think about breaking apart to the square root of negative 1 times a positive 9, right? That square root of negative 1 is I, and the square root of 9 is 3. So we usually write this as 3i. Okay, so think about this next one. You're saying, okay, we got the square root of negative 100, so negative 1 times 100. The square root of negative 1 is I. The square root of 100 is 10. And we usually just put the number in front, so we get 10 times I. Okay, this next one's a little trickier because we have the square root of -1 times 32. But 32 is not a perfect square, so we're going to have to break it down. We get 16 and 2. Then we get 4 and 4. Since I already have a pair, I'd probably just stop there. It's possible the way you broke it down that maybe you'd have 2 sets of 2 to make the 4. That's fine. So here we'd have I times, and the square root of 32 becomes 4 square roots of 2. You can either leave it like that, or sometimes I write it 4I and then the square root of 2. Either of these answers work. I would just be careful not to write the I at the end, because then sometimes people accidentally put it under the square root, and that is incorrect. Okay, so this next one, you have -1 times 76. 96, that's not 76. So 96, maybe you say, okay, that looks like it breaks down to 6 times something, so let's see what it is. 6 times 16. So then 6 breaks down to 2 and 3. 16 breaks down to like 8 and 2. Then we get 4 and 2, and then we get 2 and 2. We're looking for pairs, so I see a pair of 2s. I see another pair of 2s, and I've got a leftover 3 and 2. So the -1, the square root of -1 is the I. And then with the square root of 96, we have 2 2s, so we have 2 times 2 is 4. And then we have the square root of 2 times 3, which is 6. So here we get 4I square roots of 6. Okay. Okay, as we continue, we're going to do some more operations with I in just a minute here. I do want us to recognize what these are equivalent to. So we're going to simplify some of these. So I to the first, that's just simply equal to I, right? Anything to the first power is equal to itself. If you have I squared, though, that's saying I times I. So we have the square root of -1 times the square root of -1. Okay? We can think of that as the square root of -1, and we're squaring it, right? Because it happens times itself. What happens with squares and square roots? They cancel each other out. So we're left with just -1 here. So there's actually some properties here that are a little bit different, right? Like this doesn't just say as x to the second, right? I to the second is equal to -1. And we're going to use that idea a lot. These are the two that I would say you definitely want to know, right? I to the first you can just write as I, but I squared is the one that you definitely want to know is -1. These other two I'm just going to show you just so you understand, but generally speaking, we'll leave things kind of I to the second power. So I cubed would be I times I times I. I could maybe even say, hey, I just figured out I times I is the same as -1 times I. So it's the same as -I. I to the fourth is I times I times I times I. Since I know I squared so well, I squared, so if you do 2 i's multiplied together is -1. This is the same as just -1 times -1. So this is a +1. So there's actually some really interesting properties about I that your exponents can always be simplified. But mostly, I want you to know this one right here, right? So this one right here with the I squared, you want to know that this is -1. Okay, let's go ahead and do some operations. So we're going to add and subtract complex numbers, so meaning they have a real and imaginary part. It says, you already know how to do this, I promise. To add and subtract, you're going to combine the real parts together and the imaginary parts together. So when I have 6 plus 5i plus 8 minus 3i, you're simply going to rewrite it. I'd probably rewrite it without the parentheses first. And then you're saying, okay, I'm going to combine the real parts, so the parts that don't have I. 6 plus 8 is 14. Then I'm going to go ahead and combine the imaginary parts, which is 5i minus 3i. So I get 2i. So your final answer here is 14 plus 2i. Okay, same thing here. I'd first start by rewriting it without the parentheses. So 7 minus 3i. Then we're going to have to distribute this negative. A negative times a negative makes it positive 5, but then remember we are subtracting 9i. A lot of times, remember that negative applies to the second part too there, so make sure you apply it to both. So we've got 7 plus 5 is 12. Those are our real parts. Now for the imaginary, -3 minus 9, -3i minus 9i. should also give me a negative 12i. So your final answer here, we've got 12 minus 12i. Same thing here. Rewrite it without the parentheses. Nothing changes because it's just adding. Combine your real part, so 12 and 5 is 17. And then your imaginary parts, which is negative 3 plus 3i plus 4i is just I. So here we get a final answer of 17 plus I. Okay, next, 10 plus 6i. We're going to distribute the negatives. So we have minus 8 plus I. So let's go ahead and take a look. We've got 10 minus 8 is 2. Then we've got 6i plus I would be 7i. So our final answer here is 2 plus 7i. Okay. On this next part here, we're now going to multiply. So we're going to multiply using the box or distributive property. And then maybe I should add, make sure you simplify it, right? So we shouldn't have any exponents of i's when we finish. So you can either use your box or the distributive property. Either way works. I'll kind of show you, maybe I'll do one example of each. This first one I probably would just distribute though. Let's multiply 9 times 2 is 18i. 9i times 5i is 45. I times I is I squared. So the only thing we got to remember here is I squared is equal to what number? A negative 1. So we're really doing 45 times negative 1. So we get 18i, and then we get minus 45. You can leave it like that, or sometimes we'll rewrite it as like the negative 45, and then plus 18i, because we usually write complex numbers with the real part and then the imaginary. Okay, I will do the distributive property again, and then maybe on the next one I'll do the box. So to distribute, we got to do all the way through. So 5 times 3 is 15. 5 times 4i is 20i. Negative 2i times 3 is negative 6i. Negative 2i times 4i is minus 8i squared. Okay, 15, I can combine these two, and I get 14i. At the end here, I have negative 8i squared, though, is the same as negative 1. So this is the same as 15 plus 14i. Minus 8 times a negative 1 is really subtracting a negative 8, or you can think about negative 8 times negative 1 makes it a positive 8. Then I've got two like terms that I can combine. 15 plus 8 is 23 plus 14i. Okay. Next, 2 plus 5i squared. Be careful, you don't distribute the squared in here. That's not how this works this time, right? Remember, this is the same as 2 plus 5i times 2 plus 5i. So this one I'll draw the box for, and then you can decide which method you like better for the last one. So since we've got two terms and two terms, we draw a 2 by 2 box. We have 2 plus 5i. And then we've got 2 plus 5i. So we're going to multiply the sides of the box. 2 times 2 is 4. 5i times 2 is 10i. 2 times 5 is 10i. 5 times 5 is 25. I times I is I squared. So we get 4. We get, adding the two 10s together, we get 20i plus 25i squared. But we've already said, hey, I squared we can rewrite as a negative 1. So now we get 4 plus 20i. 25 times a negative 1 makes it a negative 25. So now I've got two like terms, and I'm doing 4 times negative 25 is a negative 21 plus 20i. Okay, one last one. This one I first would just start with rewriting. So 5 plus, since there's a negative in there, that means it's I, and the square root of 16 is 4. So that's 5 plus 4i times 2 minus, the negative in there means it's I, the square root of 9 is 3. So this is just times 3i. So that's what that problem's saying. Okay, I don't care if you choose the box or distribute it. I'm probably going to distribute. So 5 times 2 is 10. 5 times negative 3i is negative 15i. 4i times 2 is 8i. 4i times negative 3i is negative 12i squared. 10 minus, I can combine these terms, so minus 7i. I can rewrite that I squared as a negative 1. So we'd have 12 minus 7i. That's now plus 12 when we do negative 12 times negative 1. So add the 10 and the negative 12 together, we get 22 minus 7i. Okay, there's your little introduction to complex numbers. Good luck with your homework.